Introduction to Quantum Concepts. Introduction. Welcome to the intriguing world of quantum mechanics. This introductory page is designed to ease you into the quantum realm, a universe that is undeniably strange but holds the keys to unlock profound insights about the nature of our reality. Welcome to your journey into the enigmatic realm of quantum mechanics. As you embark on this exciting exploration, you'll uncover the fundamental principles that underpin the quantum universe, principles that challenge our traditional understanding of reality and open the door to new perspectives. Quantum mechanics, the study of the very small, describes the behavior of particles at the atomic and subatomic levels. It is a world that seems utterly strange when compared to the reality we experience in our everyday lives. Particles can exist in multiple states at once, thanks to superposition. They can be both a particle and a wave due to wave-particle duality. They can even influence each other instantaneously, regardless of the distance between them, through quantum entanglement. These ideas may seem mind-boggling, yet they are not mere theories or abstract concepts. They have been repeatedly confirmed through meticulous experiments over the last century, and they form the foundation for much of our modern technology, including lasers, semiconductors, and even the computer you're using to read this. In this guide, we will dive into three foundational quantum principles: wave-particle duality, superposition, and entanglement. We'll explore their meanings, implications, and their relevance to our understanding of reality. But beyond just understanding, we will also start drawing connections between these principles in our everyday lives, laying the groundwork for what we call quantum transmutation. This journey, however, is not just about understanding quantum mechanics. It's about looking at the world, the universe, and, most importantly, ourselves in a new light. It's about realizing that at the most fundamental level, we are all part of the quantum world, a world teeming with infinite possibilities. So, let's step into this fascinating realm together, a realm that extends beyond the boundaries of the observable universe and into the heart of existence itself. Welcome to your introduction to quantum concepts. Remember, this is an exploration, a journey. There is no prerequisite knowledge required, only curiosity and an open mind. So let's get started on this quantum adventure. Section 1: Wave-particle duality. Wave-particle duality is the mind-bending concept that all particles also have properties of waves. This principle challenges the traditional understanding of physical reality, blurring the lines between what we consider particles and waves. Wave-particle duality is one of the cornerstone ideas in quantum physics, and it's one that topples our traditional understanding of what we consider as particles and waves. Firstly, let's clarify what we mean by particles and waves. In the realm of classical physics, particles, such as electrons or atoms, are tiny units of matter. They have a specific location at any given time, much like a car on a road or a ball in a field. On the other hand, waves represent a continuous undulation or vibration, like ripples spreading across the surface of a pond when a stone is thrown in. In our everyday world, a particle cannot be a wave, and a wave cannot be a particle. They are distinctly different entities. However, at the quantum level, things are not so straightforward. Enter the concept of wave-particle duality. Wave-particle duality proposes that elementary particles, such as electrons and photons, paradoxically exhibit properties of both particles and waves. This doesn't mean they are sometimes particles and sometimes waves based on our convenience or interpretation. Instead, they possess an intrinsic, dual nature where they can be described as both particles and waves simultaneously. This concept was born out of experiments like the famous double-slit experiment, where light exhibited characteristics of both a wave and a particle. When we shoot light at two slits in a barrier, it creates an interference pattern typical of waves on the other side. Yet, when we measure where the light lands, we detect it as discrete packets or particles. It's essential to understand that this duality isn't just about light or electrons, it's a fundamental feature of the quantum world. Even large molecules have been observed to display wave-like behavior under specific conditions. Wave-particle duality is not just a quirky feature of quantum mechanics. It has profound implications for our understanding of reality and the nature of the universe. It challenges classical concepts of distinct identities, opening up a world of interconnectedness and fluidity. It's a bold step away from the certainty of the classical world into the realm of probabilities and potentialities. By understanding and embracing this principle, you're taking the first significant step towards quantum transmutation. But remember, this is just the start of our quantum journey. As we delve further, you'll discover how these concepts can transform not just your understanding of the universe, but your perception of self and reality. Stay tuned as we journey deeper into the rabbit hole of quantum mechanics and unveil the transformative potential of these principles in the subsequent sections. Section 2: Superposition. Superposition is another quantum marvel, describing the ability of particles to exist in multiple states at once until measured. This concept takes us further down the rabbit hole, exploring the myriad possibilities open to us in the quantum realm. Superposition, quantum potentiality. Superposition is one of the most revolutionary concepts in quantum mechanics. It refers to the fascinating and counterintuitive notion that a quantum particle can exist in multiple states at once. It's as if you could be at home and at work simultaneously. In classical physics, a system or an object can only be in one definite state at any given time. For instance, a light switch is either on or off. However, quantum mechanics allows for a particle to be in a superposition of states, a simultaneous existence in multiple states. Consider the example of a quantum bit or qubit, the basic unit of quantum information. Unlike a classical bit that can be in one state at a time, either 0 or 1, a qubit can be in a superposition of states, representing 0 and 1 at the same time. It is only when we measure the qubit that it collapses to one of the definite states. Superposition is closely tied to the wave nature of particles we discussed earlier. Just as a wave can crest and trough simultaneously at different points, a quantum particle can exist in different states at the same time. It's the observation or measurement that forces the particle to choose a state. Superposition, a doorway to possibilities. The principle of superposition takes us into a realm of infinite possibilities. Each unobserved quantum particle exists in a landscape of potentiality, awaiting the act of measurement to resolve into one particular state. What's more fascinating is that superposition isn't limited to tiny particles alone. Scientists have observed superposition in larger systems under specific circumstances. These advancements open up a world of exciting possibilities, including quantum computing, which could revolutionize our technological capabilities. But what does superposition mean for us on a personal level? How does it relate to quantum transmutation? Superposition can serve as a powerful metaphor for embracing potentialities in our lives. It invites us to consider the idea that until we measure or make a choice, multiple possibilities exist concurrently. Each decision we make collapses our life superposition into a particular state, leading us down one path among many potential ones. Just as superposition allows particles to explore multiple states simultaneously, quantum transmutation encourages us to embrace the myriad potentialities in our lives. It guides us to understand that we are not fixed entities, but rather fluid beings capable of exploring multiple paths, choices, and identities. As we dive deeper into quantum principles in the next sections, we'll uncover more about how these abstract concepts hold transformative power for our understanding of ourselves and our universe. We're just getting started on this path of quantum transmutation. Let's continue to explore and transform together. Section 3: Entanglement. Quantum entanglement is perhaps one of the most intriguing aspects of quantum mechanics. It describes the deep connections formed between particles, irrespective of the distance separating them. Entanglement challenges our understanding of space and time, suggesting an inherent interconnection within our universe. Entanglement, quantum connection. Quantum entanglement is often cited as the most mystical phenomenon in quantum physics. It tells us that particles can become interconnected, or entangled, in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. Let's imagine a pair of entangled particles. No matter the distance between them, it could be inches or light years, the state of one particle immediately correlates with the state of the other. If we were to change the state of one particle, the other would instantly change its state in response, even if it was on the other side of the universe. This instantaneous action at a distance seems to defy the limits of the speed of light set by Einstein's theory of relativity, which states that nothing can travel faster than light. However, quantum entanglement doesn't involve any physical signal passing between the particles, thereby not violating relativity. Entanglement, transcending spacetime. Quantum entanglement presents a radically different view of reality, one that transcends the boundaries of space and time. This interconnection reflects a profound level of unity beneath the surface level of the universe, challenging our conventional notions of separateness. Entanglement also suggests a level of order and coherence in the quantum world that can seem almost prearranged. The entangled particles know instantaneously about each other's states despite vast separations, as if bound by an invisible, intangible thread. In the context of quantum transmutation, entanglement speaks to our deep interconnectedness. Just as entangled particles reflect each other's states, we are deeply connected with the people and environment around us. Our thoughts, actions, and intentions can influence our surroundings, just as we are influenced by them. By understanding quantum entanglement, we can better appreciate the importance of fostering positive relationships, cultivating harmonious environments, and nurturing balanced states of mind. The awareness of our inherent interconnectedness can lead to more empathetic, compassionate, and cooperative behavior, promoting personal growth and collective well-being. In the following sections, we'll explore how the understanding of these principles can be used to navigate our personal journey of transformation. Quantum transmutation is not just about understanding these principles, but about integrating this knowledge into our everyday lives to bring about profound change. The journey has only just begun, so let's forge ahead together towards a new understanding of reality.